All right, so our learning target today is to write a system of equations from a graph, and then we're going to solve it algebraically, which is what we did last week. The first thing we need to do is write the linear equation, then write the quadratic equation, and then solve for it algebraically. All right, let's look at the first one. We're first going to write the equation of our linear function. Now, when we write the equation of a linear function, we need an m and we need a b. The m is my slope, so we need to find the rise over run. Our line is this one right here. So for right now, we're going to ignore the quadratic function. So if we look at this line, we first want to find our y-intercept. What is the y-intercept? -7. That is my b. Guys. So my b is -7. Next, we're going to find our slope. How many points do you need to find your slope? Just 2. So you want the 2 closest points. We already have 1 point here, and they're giving us another point here. So we want to go right first, and to the right, we have a change of 1. And are we going down or up? We're going down, so my rise is going to be -2. Sorry, the last one was the run. This is the run, and this is the rise. Right. So we've got -2 over 1, which gives us -2. So let's write the equation. We've got y is equal to -2x minus 7. That was my m, and then my b is -7. Questions so far? All right, now we're going to write the equation of my quadratic function. Again, we've already done this before, so let's go ahead and refresh our memory. For our quadratic equation, we need the h and the k, which is our vertex. And then we also need our a, which is like our slope. So let's first look for our vertex. We're going to now be looking at the quadratic function, which is this one here. So what is my vertex? 1, 3. Oops, wrong place. So my h is 1 and my k is 3. Then we're going to look for our a value, which is like our slope. And we always start it from the vertex. So from my vertex, I want to look for the closest pretty point. We can go this way, or we can also use this pretty point. So from my vertex to get to that point, are we going down or are we going up? From the vertex, we're going down. So we're going down 2. So that's going to be -2. Now on this one for parabolas, we can either go right or left. I'm just going to keep it consistent and go right. And that's a change of 1. So for the a value for my quadratic function, my rise is -2 and my run is 1. And because it's quadratic, we need to square it. So we simplify. -2 divided by 1 squared is -2, because it's basically -2 divided by 1. Question so far? All right, let's go ahead and substitute. We've got y is equal to, then we're going to write our a, -2, x minus my h, what's my h again? 1, squared, and then plus my k, which is 3. Any questions so far? So now that we have our both equations, now we're going to solve it algebraically. Now, if you remember from the last less than 0.7, we have to set our equations equal to each other. So let's set our two equations equal to each other. We've got our linear one, negative 2x minus 7, equals to my quadratic one, negative 2x minus 1 squared plus 3. Mr. Face in a different period. All right. When we solve, we always want to take care of the parentheses first, because in order for it to be in standard form, we get rid of the parentheses. So we need to get rid of these first. And this means we have x minus 1 times x minus 1. Question so far? From here, we're going to distribute. X times x is x squared minus 1x minus 1x plus 1. Any questions so far? We're almost done with it. And then from here, we combine like terms. We're going to combine these two, so we get x squared minus 2x plus 1. Want to bring down the rest. And we still have parentheses. How do we get rid of that parentheses? What's happening between the negative 2 and the parentheses? Multiply. So we're going to multiply these two. Then negative 2 times negative 2x, positive 4x, negative 2 times 1, negative 2. Remember, our goal is to have it in standard form so we can solve. And when we're solving, we want our x squared to be positive. So are we going to move all our terms to this side? Yes? Okay, we can do that. All right, so we're going to move this negative 2x. We're going to add it. And we're going to put it right under its like term. This will make our life easier. Then that negative 7, we can change it to what? Positive 7. And we're going to put it under the two constants that we have. All right, let's go ahead and bring it down. We've got negative 2x squared. 4x plus 2x is 6x. Negative 2 plus 3 plus 7 is positive 8. Now, what do you notice about these three terms? Do they have a greatest common factor?
Yes.
Yeah. So, if you notice, this x squared is also negative. But we can take care of both of them at the same time. So instead of dividing by 2, we can divide by what number? By negative 2. So let's go ahead and divide everything by negative 2. We've got negative 2 on the outside, and then x squared minus 3x minus 4. So whether you move your expression to this side or these to the left side, at this point, this is where you should have the same exact work or the same exact answer. And it all depends on how your brain works. If your brain works to just follow wherever the x squared is, just know how to create that positive x squared value. If it works better to move your x squares to make them positive right away, I mean, you end up with the same answer. All right, so from here, we're going to try factoring. So we've got my A, my B, and my C. And you can write on this part because it's the same problem. So let's get our A, our B, and our C because now it's time to solve. What's your A? 1. What's your B? Negative 3 and the C is negative 4. What are we going to multiply? A and C. If you're doing quadratic formula, you'll end up with the same answer. So do whatever you feel most comfortable with. So we get negative 4, and then what number goes on the bottom? Negative 3. What are we going to do to our factors? Add or subtract? Subtract them, right? Because we look at this sign. If that 4 is negative, then we have to subtract them. If it was positive, then we would add our factors. So what are the factors of 4? 1 and 4. If we subtract them, do we get 3? Yeah, so then what number has to be negative? The 4. Because negative 4 plus 1 gives us negative 3. Because my A value is 1, we can use our shortcut, which is x plus 1, x minus 4. Because we're solving, we set them each equal to 0. Then we get x is negative 1 and x is positive 4. Are we done? No, right? Because we have to find points. Right now, all we have is our x values. So I'm going to make a little rectangle over here so we can solve for y. You always want to use the linear equation because that's the easier one to use. So y is equal to negative 2x minus 7. And instead of x, we're going to plug in negative 1 first. So negative 2 times negative 1 minus 7. And that gives us negative 5. So when my x is negative 1, my y is negative 5. Now if we look at our graph, we have negative 1, negative 5. That's my first solution. So that's a way you can check it. And we're going to do the same thing to the second x value, which is 4. So we're going to have negative 2 times 4 minus 7. Negative 8 minus 7, that gives us negative 15 for my y. And for this point, when your x is 4, my y is negative 15. And then go back to the graph. Like for this part. So you can use a quadratic one, but be careful with it because the quadratic one you would have to plug in x in here and then subtract 1 and then square it, then multiply by negative 2 and then add 3. Okay, you want to use the linear one because that's the easiest one to use. But they'll both give you the same answer. All right, any questions?